So carefully you listen. Faraday's laws of electromagnetic induction. There are two laws given by Michael Faraday. The first law and second law both are based on our previous class or a previous experiments seen in this chapter. 3 experiments. I am repeating about that 3 experiments. Current due to magnet, current due to a current carrying coil, and current due to sudden change in the flow of charge, that is plug key is used. Based on that conclusions, Faraday gives those conclusions as 2 laws. First law, these are asked for 2 marks. The Michael Faraday, Faraday's first law of electromagnetic induction, or a first law. Faraday's first law is stated as the EMF is induced in a coil. The EMF is induced in a coil due to the change in magnetic flux linked with the coil. EMF is induced in the coil due to, I have shown here with the diagram, EMF is induced in the coil due to change in magnetic flux linked with the coil. This is first law. Second law. So according to the second law, EMF is directly proportional. Induced EMF in the coil is directly proportional to change in magnetic flux. Rate of change of, make a correction there, rate of change of magnetic flux linked with it. Rate of change of magnetic flux linked with it. So mathematically we can write EMF E is directly proportional to change in magnetic flux, where phi1 is the initial magnetic flux and phi2 has been changed after time t. So this can be written by removing this proportionality sign and introducing the constant k. By experimentally k is found to be as 1. So we are substituting that and we get E is equal to EMF E is equal to phi2 minus phi1 by t. And for small changes we can write in terms of differential form. So that is given as d phi by dt. EMF is directly proportional to rate of change of magnetic flux. You need to write in sentence and you need to write the formula. If only one law is asked for 1 mark, state Faraday's law of electromagnetic induction, then you need to write the second one only. If they ask only one without mentioning whether you need to explain the first or second, that time you should write the second one only. ಕೇಳ್ತಾರೆ ಎಕ್ಸಾಮ್ ಅಲ್ಲಿ ಬರೀ ಎಲೆಕ್ಟ್ರೋಮ್ಯಾಗ್ನೆಟಿಕ್ ಇಂಡಕ್ಷನ್ ಫ್ಯಾರಡೆ ಲಾ ಬರೀರಿ ಅಂತ ಹೇಳಿದಾಗ ಒಂದೇ, ಅದು ಸೆಕೆಂಡ್ ಒನ್ ಬರೀಬೇಕು. ಲಾಸ್ ಬರೀರಿ ಅಂತ ಕೇಳಿದ್ರೆ ಯು ಸಪೋಸ್ ಟು ರೈಟ್ ಬೋತ್ ದೋಸ್. Fine, first and second both you need to write Faraday's laws anta. So I am repeating, you can see over that d phi by dt, and here we are writing for minus n d phi by dt. This is for n number of turns. What is the meaning of that? Here these turns you can see, I have 4 turns here, like that they may have n number of turns. How to write the formula at that time? So you need to multiply with the n. Each coil gives this kind of expression, so n number of turns will give rise to EMF produced by the whole coils, or a whole number of coils I can say. So minus sign is introduced here. What is the meaning of minus sign? The meaning of minus sign, or the negative sign, indicates here, very important, negative sign indicates here, that is second law indicates that the current induced is always, the EMF, not a current, the EMF induced in the coil is always opposite to the magnetic flux which has produced it or which has induced it. I am repeating, negative sign indicates, negative sign in the formula indicates that the EMF induced will be opposing the cause produced it. The same reason is known as, the reason is one kind of law that is given by LENZ. So try to understand Lenz's law we are discussing now, Lenz's law. Fine, in 1834 German physicist, in 1834 German physicist Lenz. So French, you can see Frederick Lenz, complete name is Frederick Lenz. What he has given? He wanted to know why this person has given a minus sign in the formula, and he too wanted to know about that, what is happening inside the coil exactly, and he worked out with these experiments again. ಮಾಡ್ತಾರೆ, ಹೌದು ಯಾರು ಹೇಳಿದ್ದಾರೆ ಅಂತ ಸುಮ್ಮನೆ ಒಪ್ಕೊಳ್ಳೋಕೆ ಆಗಲ್ಲ, ನಾವು ಮತ್ತೆ ವೆರಿಫೈ ಮಾಡಿ ನೋಡಬೇಕಾಗುತ್ತೆ. So he, Lenz, took back those all apparatus like magnet, coil and solenoids and n number of coils and all, everything. So he started doing that experiment. When he did that experiment, he started to understand well enough the meaning of negative sign, and he concludes that as Lenz's law. Now what is this Lenz's law? Fine. So the polarity of induced EMF, he is explaining about the polarity. Let me make you clear, students. The meaning of polarity is sign or south north in case of magnet. In case of charges, it is positive and negative. The meaning of polarity anta heltini. In magnets, it is very nicely clear because the name is polarity, poles. ಅದಕ್ಕೆ ಅಲ್ಲಿ ಕ್ಲಿಯರ್ ಆಗುತ್ತೆ. ಸೊ ಪೊಲಾರಿಟಿ ಪಾಸಿಟಿವ್ ನೆಗೆಟಿವ್ ಏನಂತಾರೆ ಅದನ್ನ ಪೊಲಾರಿಟಿ ಅಂತ ಕರಿತೀವಿ. ದ ಪೊಲಾರಿಟಿ ಆಫ್ ಇಂಡ್ಯೂಸ್ಡ್ EMF is such that it tends to produce a current. It tends to produce a current which opposes the change in magnetic flux that induced it. ನೋಡಿ ಯಾವ ರೀತಿ ಇದೆ ಅಂದ್ರೆ ಯಾವುದು ಅದನ್ನ ಪ್ರೊಡ್ಯೂಸ್ ಮಾಡುತ್ತೆ ಅದಕ್ಕೆ ಅಪೋಸ್ ಮಾಡೋದು. ಅಂದ್ರೆ ಯಾರು ನಿಮ್ಮನ್ನ ಒಂದು ಯಾವುದು ಫೀಲ್ಡ್ ಅಲ್ಲಿ ಬೆಳೆಸಿರ್ತಾರೆ ಅನ್ಕೊಳ್ಳಿ, ಒಂದು ಫೀಲ್ಡ್ ಅಲ್ಲಿ ನಿಮ್ಮನ್ನ ಸಪೋರ್ಟ್ ಮಾಡಿ ಮೇಲೆ ಕೆತ್ತಿರ್ತಾರೆ ಅನ್ಕೊಳ್ಳಿ, ಆಮೇಲೆ ಅವ್ರನ್ನೇ ನೀವು ಅಪೋಸ್ ಮಾಡ್ದಂಗೆ. Who has induced? What has induced the current? What has induced the current? That magnetic flux only is getting opposition by the current which has been induced. ಅರ್ಥ ಮಾಡ್ಕೊಳ್ಳಿ. In the coil, current is induced. Due to the movement of a magnet, EMF is induced. Due to EMF, change in EMF also, you can see the current flowing in this as the deflection in the galvanometer. And after some time, what happens? In the coil, this current which has been induced becomes more in quantity. That current becomes more in quantity and it starts to oppose this magnetic flux. A magnetic field line ಅನ್ನ ಬರ್ಲಾರ್ದಂಗೆ ವಾಪಸ್ ಕಳಿಸಕ್ಕೆ ಸ್ಟಾರ್ಟ್ ಮಾಡುತ್ತೆ. ಆ ಕರೆಂಟ್ ಎಲ್ಲಿಂದ ಇಂಡ್ಯೂಸ್ ಆಗಿತ್ತು? ಅದೇ ಮ್ಯಾಗ್ನೆಟಿಕ್ ಫೀಲ್ಡ್ ಇಂದ ಇಂಡ್ಯೂಸ್ ಆಗಿತ್ತು, ಹೌದಲ್ಲ? ಮತ್ತು ಒಂದ್ಸತಿ ಸೆಟಪ್ ಆದ್ಮೇಲೆ ಆರಾಮಾಗಿ ನಿಂತ್ಕೊಂಡಿದೆ, ಸೆಟ್ ಆಗ್ಬಿಟ್ಟಿದೆ. ಇಂಡ್ಯೂಸ್ಡ್ ಇಟ್, ಫೈನ್, ವಿಚ್ ಹ್ಯಾಸ್ ದ ಫ್ಲಕ್ಸ್ ದಟ್ ಪ್ರೊಡ್ಯೂಸ್ಡ್ ಇಟ್. Your current is induced due to the flux. Current is induced due to the flux. After some time, the same current which has been induced by your flux is opposing the flux itself. Hope it is clear for the students. Let me say in Kannada. First, magnetic flux irutte. ಆ magnetic flux ಏನು ಮಾಡ್ತಾ ಇದೆ? ಕರೆಂಟ್ ಇಂಡ್ಯೂಸ್ ಮಾಡ್ತಾ ಇದೆ ಕಾಯಿಲ್ ಅಲ್ಲಿ. ಆ ಕರೆಂಟ್ ಒಂದು ಸ್ವಲ್ಪ ಹೊತ್ತು ಆದ್ಮೇಲೆ ಜಾಸ್ತಿ ಇಂಡ್ಯೂಸ್ ಆಗ್ಬಿಟ್ಟು ಏನಾಗುತ್ತೆ? ಈ ಮ್ಯಾಗ್ನೆಟಿಕ್ ಫ್ಲಕ್ಸ್ ನೇ ಅಪೋಸ್ ಆಗಿ ನಿಂತ್ಕೊಂಡ್ಬಿಡುತ್ತೆ. ಇಟ್ ಸ್ಟಾರ್ಟ್ಸ್ ಅಪೋಸಿಂಗ್ ದ, ಅದನ್ನೇ ವಿರುದ್ಧವಾಗಿ ಬರ್ಲಾರ್ದಂಗೆ ನೋಡ್ಕೊಳ್ಳುತ್ತೆ. ಮ್ಯಾಗ್ನೆಟಿಕ್ ಫ್ಲಕ್ಸ್ ನ ವೇರಿ ಆಗಲಾರ್ದಂಗೆ ನೋಡ್ಕೊಂಡ್ಬಿಡುತ್ತೆ. ಮ್ಯಾಗ್ನೆಟಿಕ್ ಫೀಲ್ಡ್ ಲೈನ್ಸ್ ಅನ್ನ ತಡೆಯೋಕೆ ಸ್ಟಾರ್ಟ್ ಮಾಡುತ್ತೆ. ಸೊ ಮ್ಯಾಗ್ನೆಟಿಕ್ ಫೀಲ್ಡ್ ಅನ್ನ ತಡೆಯೋಕೆ ಸ್ಟಾರ್ಟ್ ಮಾಡ್ಬಿಟ್ರೆ ಏನಾಗತ್ತೆ? ಮುಂದೆ ಮತ್ತೆ ಕರೆಂಟ್ ಫ್ಲೋ ಆಗಲ್ಲ. ಎಲ್ಲಿಂದ ಬಂದಿದ್ರಿ? ಅದೇ ಮ್ಯಾಗ್ನೆಟಿಕ್ ಫ್ಲಕ್ಸ್ ಇಂದ ಬಂದಿದ್ರಿ, ಅದನ್ನ ಇವಾಗ ಅಪೋಸ್ ಮಾಡ್ತಾ ಇದ್ರೆ. ಸೊ ಅದೇ ಅವರು ಲೆನ್ಸ್ ಕಂಡು ಹಿಡಿದ್ಬಿಟ್ಟು ಮೈನಸ್ ಸೈನ್ಗೆ ಇನ್ನೂ ಡೀಟೇಲ್ ಆಗಿ ಇನ್ಫಾರ್ಮೇಶನ್ ಕೊಡ್ತಾ ಇದ್ದಾರೆ. ದಟ್ ಇಸ್ ರಿಗಾರ್ಡಿಂಗ್ ದ Lenz's law. ಐ ಆಮ್ ರಿಪೀಟಿಂಗ್, ಸ್ಟೇಟ್ ಅಂಡ್ ಎಕ್ಸ್ಪ್ಲೇನ್ Lenz's law. ಇಟ್ಸ್ ಗೋಯಿಂಗ್ ಟು ಕಮ್ for 2 marks. Lenz's law. Fine. German physicist Friedrich Lenz explains about the polarity of the induced EMF. The polarity of induced EMF is such that it tends to oppose the magnetic flux produced it. You need to write this much. State Lenz's law. State Lenz's law. The polarity of the induced EMF in the coil opposes the cause produced it, or it is opposing the magnetic flux produced it. ಯಾವ ಮ್ಯಾಗ್ನೆಟಿಕ್ ಫ್ಲಕ್ಸ್ ಪ್ರೊಡ್ಯೂಸ್ ಮಾಡಿರುತ್ತೆ ಅದಕ್ಕೆ ಅಪೋಸ್ ಆಗ್ಬಿಡುತ್ತೆ ಅದು. ಫೈನ್. Lenz's law. And very important thing, one mark question comes from this Lenz's law concept. That is about, in 1 mark they are going to ask, Lenz's law gives about what information, or Lenz's law explains about what anta barutte, ಎದ್ರ ಬಗ್ಗೆ ಹೇಳುತ್ತೆ ಅಂತ. It says about the polarity, it says about the direction of induced EMF ಅಂತ ಬರಿಬೇಕು. It gives the information about change in polarity ಅಂದ್ರೂ ಬಂದ್ಬಿಡುತ್ತೆ. Polarity ಅಂತ ಬರೆದ್ರೂ ಕೂಡ ನಿಮಗೆ 1 mark ಬರುತ್ತೆ. Fine. Remember. ಅಥವಾ which law explains about the polarity of the induced EMF in the electromagnetic induction ಅಂತ ಕೇಳ್ತಾರೆ. ಯಾವ law? Lenz's law. I am repeating 2 questions which can arise from this. After the statement, which law opposes, which law explains the change in polarity, or the polarity, which law explains about the polarity in electromagnetic induction? The question if comes like this, the answer is Lenz's law. And one more question can be set on this. Lenz's law explains about, fine, dash, fill in the blanks antu iralla, but ade Lenz's law explains about what quantity or what matter anta kedadre it is going to explain about the polarity. Okay, polarity of the induced EMF in the EMI. Okay, remember well enough. Next is about the Lenz's law and electromagnetic induction, conservation of energy. Lenz's law and Lenz's law with electromagnetic induction and energy conservation. ಯಾಕೆ ಅಪೋಸ್ ಮಾಡುತ್ತೆ ಅಂತ ಡೀಟೇಲ್ ಅಲ್ಲಿ ಹೇಳ್ತಾರೆ ಇವಾಗ. ಯಾಕೆ ಅಪೋಸ್ ಮಾಡ್ತಾ ಇದೆ? Let us see now. This is the coil which is useful in many explanations. Once the magnetic field lines are pushed towards the coil, these magnetic field lines, they are going to push the electrons. The mechanical force which we are applying in pushing that magnet will be now turned into magnetic flux. That magnetic flux pushes the electrons in the wire, and those electrons starts to be pushed inside the wire and they induce the current. They are storing kind of energy, induced current. So what's happening? Where your current went? Just think over it. Is there any connection to this coil apart from a galvanometer? Galvanometer ಅಲ್ಲಿ ಡಿಫ್ಲೆಕ್ಷನ್ ತೋರಿಸಿದಾದ್ಮೇಲೆ ಕರೆಂಟ್ ಎಲ್ಲಿ ಹೋಗ್ಬೇಕು? ಮತ್ತೆ ಜಾಗ ಇದೆನಾ ಎಲ್ಲಾದ್ರೂ ಹೋಗೋದಕ್ಕೆ? ವೇಸ್ಟ್ ಆಗೋದಕ್ಕೆ ಏನಾದ್ರೂ ಇದೆನಾ? ಸ್ವಲ್ಪ little amount of energy can go in the form of heating the wire. In the form of heat it can get wasted, but that is very less, negligible. Here, once after showing the deflection in the galvanometer, the current starts to flow in a reverse order, which makes the work just, it is making your magnetic field to push back. ವಾಪಸ್ ಅದಕ್ಕೆ ಅಪೋಸ್ ಮಾಡಕ್ಕೆ ಸ್ಟಾರ್ಟ್ ಆಗುತ್ತೆ. ಆವಾಗ ನಾವು ವರ್ಕ್ ಮಾಡಬೇಕಾಗುತ್ತೆ. ಅದು ವಾಪಸ್ ಕಳಿಸ್ತಾ ಇದ್ರು ನಾವು ಪುಷ್ ಮಾಡಬೇಕಲ್ಲ. ಸೊ ದಟ್ ಈಸ್ ಗೋಯಿಂಗ್ ಟು ಬಿ ರಿಲೇಟೆಡ್ ವಿತ್ ಯುವರ್ ಕನ್ಸರ್ವೇಷನ್ ಆಫ್ ಲಾ, ಕನ್ಸರ್ವೇಷನ್ ಆಫ್ ಎನರ್ಜಿ ಲಾ. ಓಕೆ, ಎನರ್ಜಿ ಕನ್ಸರ್ವೇಷನ್ ಲಾ, ವಾಟ್ ವಿ ಕ್ಯಾನ್ ಸೇ. Physical significance of Lenz's law anta kelidre, it gives the physical significance of Lenz's law gives that energy conservation. ಏನು ನೀವು ಹಾಕಿರೋ ಎನರ್ಜಿನ ಅಲ್ಲಿ ಪಡ್ಕೋತಾ ಇದೀವಿ. Energy neither be created nor be destroyed. It has changed from one form to another form. Magnet, ನಮ್ಮ ಫೋರ್ಸ್, ಮೆಕ್ಯಾನಿಕಲ್ ಫೋರ್ಸ್ ಮ್ಯಾಗ್ನೆಟಿಕ್ ಫೋರ್ಸ್ ಆಗಿ, ಆ ಮ್ಯಾಗ್ನೆಟಿಕ್ ಫೋರ್ಸ್ ಎಲೆಕ್ಟ್ರಿಕ್ ಕರೆಂಟ್ ಆಗಿ ಆ ಎನರ್ಜಿನಲ್ಲಿ ಬರ್ತಾ ಇದೆ. ಓಕೆ, so physical significance, what we call about this Lenz's law and physical significance. And polarity is very important, you should remember well enough. Lenz's law is stated already, as you can see over that. So physical significance also said about that. So next is about what is known to be as a motional EMF. Motional EMF. So very interesting thing, motional EMF, and it is for 5 marks derivation. 5 marks derivation. Okay, let us see over that. What is there in a 5 marks derivation? Sequence of energy conservation law with Lenz's law. Lenz's law gives about the information regarding energy is conserved in this case also. How it is conserved, let us see now. When north side of the magnet is pushed towards the coil, due to the magnetic field around the magnet will push the electrons in the side by coil, and those electrons starts to flow in the coil, which induces current. Once the current is induced inside that coil, it generates magnetic field around it. That magnetic field now is in anti-clockwise direction according to the right hand thumb rule. That magnetic field induced in this coil is in a anti-clockwise direction, which behaves like a north pole. So since it is behaving like a north pole, it is getting repelled. This north pole is getting repelled. So this is the way how we can say Lenz's law. It opposes the cause producing it anta yaake helidvi andre, illi generate ago magnet, illi first enagutte, electrons are pushed. Ellinda? E magnetic field inda. Idu permanent magnet idella, ಅಲ್ಲಿಂದ ಮ್ಯಾಗ್ನೆಟಿಕ್ ಫೀಲ್ಡ್ ಲೈನ್ಸ್ ಇದ್ರ ಮೇಲೆ ಬಿದ್ದು ಮ್ಯಾಗ್ನೆಟಿಕ್ ಫ್ಲಕ್ಸ್ ಡೆನ್ಸಿಟಿ. ಸೊ ಎಲೆಕ್ಟ್ರಾನ್ಸ್ ಮೂವ್ ಮಾಡುತ್ತೆ, ಎಲೆಕ್ಟ್ರಾನ್ಸ್ ಕರೆಂಟ್ ಫ್ಲೋ ಆಗುತ್ತೆ, ಕರೆಂಟ್ ಫ್ಲೋ ಆಗಿದ್ ಮತ್ತೆ ಕರೆಂಟ್ ಕ್ಯಾರಿಂಗ್ ಕಂಡಕ್ಟರ್ ಇಂಡ್ಯೂಸಸ್ ದ ಮ್ಯಾಗ್ನೆಟಿಕ್ ಫೀಲ್ಡ್, ಪ್ರೊಡ್ಯೂಸಸ್ ದ ಮ್ಯಾಗ್ನೆಟಿಕ್ ಫೀಲ್ಡ್ ಅರೌಂಡ್ ಇಟ್ ಅಲ್ಲ. ಸೊ ಮ್ಯಾಗ್ನೆಟಿಕ್ ಫೀಲ್ಡ್ ಇಲ್ಲಿ ಮತ್ತೆ ಜನರೇಟ್ ಆಗಿರುತ್ತೆ ಅರೌಂಡ್ ಕಾಯಿಲ್. ಸೊ ದಟ್ ಮ್ಯಾಗ್ನೆಟಿಕ್ ಫೀಲ್ಡ್ ಇಸ್ ಇನ್ ಆಂಟಿ ಕ್ಲಾಕ್ ವೈಸ್ ಡೈರೆಕ್ಷನ್. Then it is behaving like a north pole, which makes the further movement difficult. When it is behaving like north pole, it is not allowing our magnet to be pushed now. In the beginning it was allowing, now it is not allowing. Why? Because the current flowing in the coil has induced the magnetic field. That magnetic field is in anti-clockwise direction, behaves like a north pole, and according to the nature of the magnet, north pole repels with the north pole. So that is the case. Here is the work done, and that work done is in the form of pushing back is nothing but energy. So it is gaining kinetic energy, which gives the information regarding what I can say is conservation of energy with the Lenz's law. Very simple thing, but it is asked for 2 marks. Explain the consequence of conservation of energy with the help of Lenz's law. What do you need to write? You need to draw this. Fine, any one of this is enough. When the north side of the bar magnet is pushed towards the coil connected to the galvanometer, electrons flows and current is induced in the coil, and induced current produces the magnetic field around the coil, which is in anti-clockwise direction, and it starts behaving like a north pole, which makes the bar magnet north pole to be repelled by it. When it is getting repelled, kind of kinetic energy is seen in the bar magnet. Find kinetic energy. So this is in consequence with the energy conservation law. Remember well enough, energy conservation law. So when north pole goes towards the coil, it must develop north pole only. When south pole goes towards it, when you may be having the question that instead of north pole miss na south pole akad ಮಾಡ್ತೀನಿ ಏನಾಗುತ್ತೆ, ಆವಾಗ ಆಟೋಮ್ಯಾಟಿಕ್ ಆಗಿ ಎಲ್ಲ ಡೈರೆಕ್ಷನ್ ಚೇಂಜ್ ಆಗ್ತವೆ. I said in the previous experiments only, once you change the polarity, the deflection in the galvanometer changes, we said. Why the deflection in the galvanometer changes? Because the flow of current direction changes. Once the flow of current direction changes, the magnetic field produced by it also changes its direction. That time the coil will be having the magnetic field in a clockwise direction, and those clockwise magnetic field lines will be behaving like a south pole, and you are just pushing your south pole towards that. So again it is getting repelled. Okay, this is the case what we have discussed. The next is regarding motional EMF. Motional. Emotional alla, motional. What is the meaning of this motional EMF? Concept is very simple. We have a magnetic field. We have a magnetic field. And we are moving current carrying conductor in it, or else just move one conductor in it. Try to imagine. You have a magnetic field. Already field lines are going. And let us take one wire piece and just make it to be moving in that field. ಏನಾಗುತ್ತೆ ಯಾವ ತರ ಇಮ್ಯಾಜಿನ್ ಮಾಡ್ಕೋಬೇಕು? ಮ್ಯಾಗ್ನೆಟಿಕ್ ಫೀಲ್ಡ್ ಇದೆ ಎಲ್ಲ ಕಡೆ, ಒಂದು ವೈರ್ನ ಸುಮ್ಮನೆ ಅದರಲ್ಲಿ ಓಡಾಡಿಸ್ಕೊಂಡು ತಂದುಬಿಡೋದು. Is there any effect? Yes. How and what? Once the conductor is moving, the electrons inside that conductor are getting disturbed by the magnetic field and the motion of the conductor. And once they get disturbed, they start flowing in that conductor. What is the meaning? Current starts to flow in the wire. Current starts to flow in the wire. ಅದಕ್ಕೆ ನೋಡಿ experiments, Faraday and Henry experiments ಅಲ್ಲಿ ಏನು ಹೇಳಿದ್ರು? Either you move the magnet towards the coil, or keep your magnet there only, move your coil. Coil stationary ittu magnet move ಮಾಡಿ, ಇಲ್ಲ magnet stationary ittu coil move ಮಾಡಿ. ಇದು ಅದೇ ಥರದ ಕೇಸ್. ಮ್ಯಾಗ್ನೆಟಿಕ್ ಫೀಲ್ಡ್ ಕಾನ್ಸ್ಟೆಂಟ್ ಇದೆ, ನಾವು ಸುಮ್ಮನೆ ಸಿಂಪಲ್ ಒಂದು ಸ್ಟ್ರೇಟ್ ವೈರನ್ನ ವೈರ್ ಫ್ರೇಮ್ ರೆಕ್ಟಾಂಗ್ಯುಲರ್ ವೈರ್ ಫ್ರೇಮನ್ನ ಅದರೊಳಗಿಂದ ಜಸ್ಟ್ ಪಾಸ್ ಮಾಡ್ತಾ ಇದ್ದೀವಿ ವಿತ್ ವೆಲಾಸಿಟಿ v. What EMF it is induced? EMF induced in the coil moving in magnetic field is called motional EMF, is called motional EMF. The EMF is induced due to the motion of the wire in the magnetic field ಅಲ್ಲ ಅದಕ್ಕೆ motional EMF ಅಂತ ಕರೀತಾರೆ ಅರ್ಥ ಮಾಡ್ಕೊಳ್ಳಿ. You have a magnetic field, the wire is or wire frame is moving in that magnetic field with velocity v. Due to that motion EMF is induced, it is called motional EMF. It's asked for 1 mark. Define or what is motional EMF. The EMF induced in a conductor moving in plane perpendicular to a magnetic field. EMF induced in the conductor in the plane perpendicular to the magnetic field is called motional EMF. In the field is called motional EMF. Remember well enough? Now 9 minutes for me to derive that. Let me check over that how we will derive. I want you to write that because it is of 5 marks.